Hello everyone. As a part of our NCERT series, we are discussing 7th class Geography NCERT, our environment. In this video, we are going to discuss our changing Earth. Our changing Earth. So before taking up this chapter, I just wanted to tell few important points, which I have already discussed in my previous videos. One of my video explains the interior of the earth. So interior of the earth has been divided into three parts. One is crust, mantle and the core. Crust is composed of rocks, minerals, and the upper layer of the crust has been covered by soil. So crust is of two types, continental crust and oceanic crust. So this crust has been divided into several large, some small, rigid, irregularly shaped plates. So these plates are carrying continents as well as ocean surface. So these lithospheric plates, I'm using the term lithospheric. What is lithosphere? Lithos means stone in Greek language. So these lithospheric plates constantly move in relation to each other. That means they move very slowly. Okay, so they move a few millimeters in a year. And naturally we get a doubt how these plates are moving in relation to each other. So reason behind is molten magma. So molten magma is present in the mantle region. So how this molten magma moves? Molten magma moves in a circular manner. Okay, so when we talk about the circular manner of moving, so I just wanted to tell a process that is convection. So I just wanted to use a term which is not given in this chapter, that is convectional current. So convectional currents are responsible for the movement of these plates. So the movement of these plates are responsible for the changes on the surface of the earth. Okay, so these movements are divided depending upon the forces which act on them. What are the forces which act on these movements? There are two forces. One is endogenic force, another one is exogenic, and we can also use endogenic or else exogenic. What is the meaning of endogenic? Means these forces are originating inside the earth. That means these forces act in the interior of the earth. And what about exogenic forces? So those forces are originating outside. That means these forces, exogenic forces, work on the surface of the earth. So these endogenic forces are responsible for two types of movements. One is sudden movement, another one slow movement. Sudden movements causes earthquakes and volcanic eruption and landslides. Slow movements responsible for mountain building activity. And mountain building takes place millions of years. So that is a slow process. In this chapter, we are going to discuss two sudden movements. One is earthquake, another one volcano. Let us see one by one. Now look at volcano. What is volcano? Volcano is nothing but an opening, that is a vent in the earth's crust. So this vent allows molten material which comes from the mantle. Okay, so this molten material contains magma, ash, water vapor and other important gases. All these things erupt at once, suddenly. So this is about volcano. Now we are going to take up earthquake. So in simple definition, earthquake is nothing but a vibration on the earth. So how this vibration takes place? Look at this. So this is a focus from where energy released. The release of energy from this region, okay, wherever energy releases at first, that region is focus. When this energy is released, it travels in all directions in the form of waves. So these waves reaches the surface of the earth, which is perpendicular to the focus. So that place is epicenter. That means epicenter is the region which experience earthquake. Okay, so that is the first place to experience earthquake, epicenter. That means maximum damage occurs at epicenter. Okay, so now I'm talking about the waves. So these waves were generally measured by seismograph. Okay, seismograph. And the magnitude of the earthquake could be measured by using a Richter scale. Whenever the magnitude is 2.0 or less than that, we may not feel the vibration. And if it is 5.0, we can see some kind of damage due to the vibration. And if it is 6.0 and more than that, the destruction, damage, everything is maximum. I'm talking about waves. So energy released and traveled in the form of waves. So these waves were divided into two types. One is body waves and surface waves. So these body waves are again divided into two types. That is P wave and S wave. P waves are also known as longitudinal waves. And S waves are transverse waves. So these body waves travel in the interior of the earth. And what about surface waves? Surface waves travel near the surface of the earth. That means just 1 or 2 kilometers below the surface. Okay, so these surface waves are again divided into two. One, that is love waves or L waves. And another one is Rayleigh waves. Actually, in this chapter, they have mentioned only 3 waves, P, S and L. They did not give Rayleigh waves. So, these earthquake waves are divided into 4 types in general. It is very difficult to predict earthquake. And the impact could be minimized. So, generally, local people, they try to predict and they adopt different methods to predict earthquakes, but it is very difficult. And they generally try to observe animal behavior, maybe snakes, fishes, like that. And even preparedness is most important thing here. So one should spread awareness among families and friends. And also one should protect himself by covering himself under the table. One should avoid fireplaces. And also they should avoid those windows which were covered by glasses. So these are some of the important things which we have to follow during earthquake. Now we are going to take up another important part in this chapter, that is exogenic forces. These exogenic forces are responsible for various landforms on the surface of the earth. And there are so many agents, okay, which are responsible for erosion and deposition. So those agents are river, wind, sea waves, glaciers. There are 2 processes, weathering and erosion. These 2 processes generally own out the landscape. Okay, there is a clear difference between weathering and erosion. Clear difference. What is weathering? Weathering is the breaking up of rocks on the earth's surface, and these broken rocks would remain at the same place, that is in situ. If you look at erosion, so wearing of landscape by various agents. Example, sea waves, glaciers, and wind, water, that is especially running water. Okay, so these are agents which are responsible for erosion of landscape. These agents they carry that eroded material from one place to another place and finally eventually deposited at one place. So this erosion and deposition is responsible for forming various landforms on the surface of the earth. Now look at these agents one by one. Now river. What the river is going to do? River is nothing but a running water. This running water erodes the landscape. So when it is flowing, it encounters hard rock as well as soft rocks. So over a period of time, because of this erosion, so river at some places, it plunges down and forms a waterfall. That means it tumbles at a steep angle and forms waterfall. Okay, when this river enters into the plain area, so generally a river erodes the landscape. While eroding that landscape, it carries various sediments along with its water. So when this river enters into plain area, this sediments gets deposited in its course. So when these deposits are obstructing its course, it twists and takes a turn. And again, this erosion and deposition is a continuous process. When this particular place is obstructed, again it takes a different turn. Like this, large bends form. So these bends were formed by its course. So these bends are known as meanders. So this erosion and deposition is a continuous process. So when this river, look at this particular point, here a river once upon a time it was flowing like this. So whenever this deposition is more and more, okay, so this loop, this particular bend is coming closer and closer, and instead of going river in this forming a big loop, river changes its course in due course and it moves like this. That means this particular bend has been cut off from the river. So that bend now it turns into an oxbow lake. So this oxbow lake is another landform. So this oxbow lake is another landform created by this running water. And when this river carries huge amount of water, generally the water overflows its banks. So when it overflows its banks, naturally this water floods the nearby neighboring areas. So when river enters into neighboring area, not only the water, it also takes sediments along with it, and these sediments get deposited here. When these sediments get deposited here, so it looks like a floodplain, because that floodplain is a fertile one because of these sediments and also a flat one. When water recedes, these deposits, these higher banks remain like that. These higher banks are known as levees. When this water approaches sea, the flow of river reduces. When the flow of a river reduces, naturally whatever load it is carrying, it would deposit. So when the river deposits its sediments, what will happen? It naturally breaks up into different streams. So these streams are nothing but distributaries. Look at this one. These distributaries are having its own mouth everywhere and finally drains into the sea. And look at these sediments, how these sediments are looking like that. And all these sediments combine together and forms a delta. See? Okay. Now, take up another important agent, that is wind. So, look at this one. So, wind is an active agent of erosion and deposition in the desert. Whenever wind blows, so the grains of sand lifted and transported from one place to another place. So whenever there was no wind, this sand generally falls down and deposited, and look at this one, and it deposited in the form of a low hill, and these are sand dunes. When sand grains are finer and lighter, generally wind carries that particular finer particles to a greater distances, that means distant places, and deposits in large areas. That is what we know as loess. So naturally, a large loess is found in China. You may come across a huge rock kind of structures in the desert. So those rock structures are like this. So as I told you, wind is an active agent of the desert. So this wind naturally it lifts these sand grains, and when it moves, okay, so these rocky structures may obstruct the flow of wind. So when it obstructs, the sand particles which it is carrying would be splashed in the lower section of this rock. So over a period of time, because of that splashing, this lower section would become narrower and the upper would remain wider. So these rocks would look like a mushroom shape. So that's why these rocks are called mushroom rocks. These mushroom rocks are the characteristic features of the desert. Okay, now take up another important agent, that is glacier. Okay, so look at this glacier. What is glacier? Glacier is nothing but a frozen river. That means rivers of ice. So depending upon the slope, so naturally these glaciers are formed in the mountainous regions. So depending upon the slope, glacier generally moves down. When the glacier starts moving down, and naturally it bulldozes soil and other silt and small stones, and it exposes other important rocky structures beneath. And the sand, silt and the stones which it carries generally deposits and forms a glacial moraines. Like whenever it also, while moving down, it also carves out a deep hollow structure. So whenever ice melts, these hollow structures gets filled up with water, and that hollow structure becomes a lake. Now look at another important agent. What is that? Okay, look at the sea wave. Sea wave is also another important active agent which are responsible for creating various landforms in the coastal area. These sea waves generally strike at the rocks which are located in the sea or else located on the shore. So these rocks continuously strike by sea waves, and these rocks slowly develop cracks, and these cracks become larger, and a cave kind of hollow was formed due to the action of sea waves. These cave hollows are known as sea caves. Okay, so over a period of time, due to the erosional activity of sea waves, these caves have become even bigger, and slowly these cavities would become larger and the entire part would be eroded. Okay, so this entire thing would become a open, due to the erosion, and only the roof-like structure would remain. This is known as sea arch. The action of sea waves would finally strike at these roofs, and finally these roofs may collapse. And these wall-like structures would remain in the sea. So these are known as sea stacks. Now look at another important structure, that is sea cliff. What is sea cliff? Sea cliff is nothing but a steep rocky coast rising vertically above the water. Okay, so it looks like this. So this is sea and this is a rocky structure. You would come across this kind of structures, landforms in the North Sea or in the Ireland area. What about the depositional activity of sea wave? So what is that? So generally sea waves carry lot of sediments. So these sediments are deposited along the seashore. Because of this deposition of sediments, it forms a beach. So this is all about our changing earth. Okay, we are going to meet in our next video. Thank you so much.